Okay, so we have now figured out how to graph in vertex form when you have an a value of 1 or if you have an a value that is larger or smaller than 1. Now we're going to graph from standard form. So standard form, to remind you, is y equals ax squared plus bx plus c. So for instance, something like this. So the easiest way to graph this is to say to yourself, well, how can I get this into vertex form? Because if I could put this equation into vertex form, then I would know how to graph it. All right, so there's a couple of steps in order to do this. The first step is you need to find the x value of the vertex, or that h value, and there is a formula to do that. The formula is h is minus b divided by 2a. So if you remember, the coefficient in front of the x squared is your a value, so in this case it's 1. The coefficient in front of the x is your b value, so in this case it's 4. And then the constant at the end is your c value, so it's 3. So you'll plug those numbers in. Minus the b value is 4 over 2 times the a value of 1. And if I reduce minus 4 over 2, I get negative 2. So now we know the h value of the vertex is negative 2. The second step is to figure out what the k value is, and you're going to go back to your original equation, and you're just going to substitute in this h value of negative 2 in for every x you see. So your k will be negative 2 squared plus 4 times the negative 2 plus 3. This is just plugging the negative 2 into your original equation. Simplify this down, and you get k is negative 1. So now we know the vertex is negative 2, negative 1. Well, if you remember from the equation that we were looking at, our a value was 1. So now we know both the vertex and the a value, so we can plug those in, and now we have the equation in vertex form. Well, now that it's in vertex form, we know how to graph it. Right? The vertex is negative 2, negative 1. The a value is 1, so we're going to use our standard values. We're going to go over 1, up 1. We're going to go over 2, up 4, or we can reflect it. And then we're going to go over negative 2, up 4, and connect our dots. All right, let's try another one. All right, so here's our equation. First step we have to find is our h value using the formula minus b over 2a. Our b value is 16. 2 times our a value would be 2 times negative 2, so it's negative 4. We have two negatives here, so 16 divided by 4 would become a positive 4. Now we find the k value by substituting this 4 in for every x in our equation. So we'll have negative 2 times 4 squared plus 16 times 4 minus 29. Simplify this all down, and we have a k value of 3. So now we know the vertex is 4, 3. Again, all we have to do is look at the original equation to find out that our a value is negative 2, and we have everything we need in order to put this equation in vertex form. So here's the equation in vertex form. Now we know how to graph it. Plot our vertex, which is 4, 3. Use our a value of negative 2 in order to get our points. So from our shifted vertex, normally we would go over 1, up 1. But because our a value, or our y multiplier, is negative 2, we're going to go over 1, down 2. Normally we would go over 2, down 4. But we have a y multiplier of negative 2, so we have to take that 4 and multiply it by negative 2. So we're going to go over 2 and down 8. And then we can reflect these points and draw in our parabola. All right, why don't you put the video on pause and see if you can do this one on your own. All right, h value minus b over 2a. b is negative 3. 2 times 1/2 is just 1. A negative times a negative is a positive, so now we know the h value is 3. Take this 3 and plug it in for every x in your equation and simplify down, and you get k is negative 2.5. Now, just because it's a fraction, that's okay. We'll just have to estimate it when we graph it. So now we know our vertex is 3 and negative 2.5. Our a value is 1/2. So this is what the equation looks like in vertex form. We're going to go ahead and graph it. We'll graph our vertex. Again, we'll just estimate 3 and then down about 2.5. From this point, we're going to go over 1. Normally we'd go up 1, but now we have to go over 1 up 1/2. Normally I'd go over 2 up 4, but I have to multiply it by half, so I'm going to go over 2 up 2. And I'm going to reflect those points. You notice again here that your parabola is wider than the parent function because our a value is smaller than 1. All right, let me know if you have any questions.